those over here. You don't have those.
I have to set up another one.
Somebody was more important than me. Okay, that's fine. I get that. No problem. Do not slip up. Okay, so we are starting chapter 2. Oh, before I forget, we have a computer science club. The students are trying to build it. It's a wonderful thing. It's good for your resume. It's good for mingling with other students. You can come up with the ideas that you have, and it's a good thing. It does happen Thursdays at 12 o'clock. Do not tell me you have a class. Nobody has a class on Thursday at 12 o'clock. So sometimes they bring pizza, sometimes they have a little budget, but you guys can do something. So the things that we are, Thursday is my day off, so I might make some time to come over here. So the things that we are trying to do is make some field trip, talk about some conventions happening over there. We have some good students in there. Some people want to talk about hacking. Some people want to talk about security, that's the other side of the hacking. One of the guys is writing games in HTML5, which is getting very hot, and actually they invited him to go talk in one convention in San Francisco. We have some good knowledgeable students over there. And it doesn't have to be all about the school. I think you guys can go in there and make it fun. It doesn't have to be all about studying and schooling. You can figure out the things. Most important thing is some technology news, things that are happening, and of course some internship or some work that comes up. I think it's going to look very good in your resume if you say that you were part of. Remember, more and more industries are looking for programmers who can work with others. That's the biggest problem we have in industry. We as a programmer, we cannot get along with other people. We have to change that, because in real life, there is no, I mean, a small company is okay, but if you really want to make a program that's going to work for a complex program, usually it's not one person. So showing that you went to a club, showing that you were part of a team, it makes a big difference in being hired for those who are looking for a job. Okay, any questions, anything before we start? You good? All right. So we are starting with chapter 2. Did you go over chapter 2? No, we went on chapter 1 only, right? Okay. So we're going to be talking about the variables. We're going to be talking about the input-output, data types and expressions, simple flow of a control and program style. So first we're going to talk about the variables. Okay. So remember, the program is going to be sitting in the memory when we're running it. So somewhere, somehow, we're going to define a space in the memory. You guys start doing that in your other book. So somehow we have to connect the program to that piece of the memory. For here, we're going to be using a variable. Okay, the variable name is going to be related to address in the memory. So I can go in there and write or pick up the value. And what else? We can write a value in them, we can change the value, we cannot erase the memory location. So when I say I need this much space for this variable in C, C++, and Java, it's going to go create that space in the memory. So as far as my program is running, that space is available in the memory. So even if I don't have nothing in there, it's going to be available. So one of the things that we're going to be working on is going to be efficiency. So if I need only this space and I go get this much space in the memory, that is not efficient. So that's some of the things that we're going to go over it. Display 2.1. So here, one of the things that I will emphasize when I first start writing program, I start with, the things I liked with the C was I can define my variable or write program very, very small. But very soon I find out that even me coming back to my program doesn't make sense. So I force myself, and I learned it in the software engineering, that the variables have to have a meaningful thing. So we say one weight, total weight, number of bars, A, B, C is not acceptable. So keep that in mind, and I'm typing it right down. That if I see your variable name A, B, C, one character, or doesn't have any meaning, you will be deducted points. So your variable should have, remember that's not my, I don't like it myself, but we all have to do it because that's a good practice of writing programs. So we talked about the C out and C in. So C in is going to take whatever is coming from the keyboard and put it in that variable. So we're going to display it and then we're going to put it in the variable. One of the things I talked before is if I have a bunch of C outs, I do not need to put all of them together. As far as I take the semicolon out of here, so if I take this semicolon out, this semicolon out, this semicolon out, and I only have one here, I can omit all the C outs. I don't have to have all the C outs. I can have one C out here, one semicolon here. I also can put them right after each other. I can put the \n in the beginning, in the middle, anywhere I want to. So it doesn't have to go to the next line. So technically I could put this one, and right after \n I could have total weight is, and then I put all these things right in one line. So different types of programming, work on those things. So for example, I had somebody, it's a \n, I had the /n, and it was displaying on the output /n. I take that as a careless mistake. In real life, that's going to be a big mistake because you're supposed to look at your own output before you give it to other people. And if I'm reading my output and I see /n, then I should go back and fix it. Any question on this code? So that would be the sample dialog. We're going to be working on putting your sample dialog on the bottom of our page and some comments on the top of the page. So from now on, every program that you write, on the top you're going to have a description of the program. I'm going to show you a sample. What's coming into the program, what's coming out of it, and at the bottom you're going to have a sample run of your program. So you will look at your sample run. If there is something wrong here, you have to fix it. So we are going to be working on a meaningful names. The first character must be a letter. The underscore is also acceptable. In conventional way, the underscore, we use it for some other stuff, but I'm not worried about it right now. Remaining characters must be letters, number, underscore. So we cannot use a special character for it. We have some keywords, meaning that there are some words that has a special meaning in C++ compiler. When you're using this compiler or any other compiler that is good, it's going to show you those keywords, it's going to change the color. I cannot use those keywords as my own variables or identifiers. Those are reserved. It doesn't let me to put something in there or take it out because it has a special meaning for it. So it cannot be used as an identifier. These are good questions for the test, huh? We have to tell what type of a variable do we have. So we will go over these things. They have different sizes. So for example, int means integer, means that we're going to have a number with no decimal. So if I have a number that doesn't have a decimal, I shouldn't be putting it in a place that needs space for the decimal point. The next one is a double. That is going to be taking a decimal, and we're going to look at the size of those things. So for the first one, the integer is going to keep numbers with no decimal, 3, 102, 3011 minus 456 and so on. And then the next one, it can be 1.34, 4.0, and so on and so forth. Yes, sir.
Why do they use double for representing something that's fraction?
We're going to look at the size of these things. So the original one is that they have different sizes as how much of room do we need in the memory for our program to run. So we have float, which is a decimal thing, and double is basically double size of a float. That's what they call double. And the short is half size of that. We're going to look at the sizes, and then we're going to look at those things. So to write a program, we're going to have a main. So this is a function. We're going to look at that later on. Int means it's going to return an integer, but for now we're going to have a braces, open and close. Some of these compilers, as soon as you open a braces, it's going to close it right away. I do that too if it doesn't do it for me. That way I'll be sure that I'm matching up with the braces. The hardest thing sometimes in a large program is to match your braces. You have one brace one way and then you cannot find the end of it and it doesn't do it. So what else? When you have braces, next block of code, you're going to indent it. So very easily you can say this is beginning, this is end. So if I have some other stuff here, I'm going to indent it too. So it's going to be very easy to read. So we can put a data type and then we can put commas after that, or we can define them one by one. So in this case I have a double, then I have average, comma, m underscore score, comma, total score, and then I have a semicolon. Semicolon is going to end this whole thing. Okay, I could potentially put another comma and put this moon distance next to it, or next line, doesn't matter. But when I go to the next line, I have double and then I have a semicolon. So this one is going to end up this same thing over here. So I can separate them with a comma, but the semicolon has to end my data type. So you can see the difference between these names, like average, instead of putting A, and moon distance instead of putting M, because right now maybe it's going to make sense, but believe me, you're going to come back to it 6 months down the road, it's not going to make sense. We can assign things to each other, so we can add and put it into something. So when we have assignment, the right side is going to happen first, and then the value is going to be calculated and it's going to be put on the left side. Okay. One of the things that we're going to see later on is that the equal sign is not checking for equality. It is assignment sign. That means it's going to take the right side and put it on the left side. It is not checking for equality. So that's one of common mistakes that we do in the programming in C++, and we're going to see that. The comments, we have two ways of putting comments. One is going to be the double forward slash. This is going to get the comment from starting of double slash to the end of the line. So that means the compiler is not even reading what's happening after this. We can declare the variable and then assign a number to it. So if I know the original value, I can just go and when I'm declaring the variable, I can assign the number to it. So remember, the left one, I'm not worried about it. If I have assignments in my program, left one, I'm not worried about it. But the right variables have to be initialized at the beginning of my program. The problem with that is if I don't do it, and I don't have any value for that variable, it's going to use whatever was left over in the memory. And sometimes those things are not pretty. So C++ is trying not to crash. So Microsoft mind is everybody is dumb, so we're going to help them as much as possible. C++ is thinking that you are a smart programmer. We're going to try to rely on you so we can do things differently. Another way of initializing the value, we can just put it inside the parentheses. So either we can put an equal sign or we can put a parenthesis. Questions so far?
So it's saying you can declare and initialize at the same point?
That's correct.
So you could just write double MPG parentheses 0.6.3 like in the body of the program and it would know?
Right, at the beginning of the program. You can do it anywhere in your program, but I like to do it at the beginning so it's going to be clear when you're going down. Yes. Yes, that's correct. When you're declaring your, that's what it says over here. So one way is you're declaring it, you assign it somewhere into your program right away, or you can do it right in the declaration to assign it. Good question. Anybody else? So how are we going to declare and initialize two variables, one int and one double? Both should be initialized to appropriate form. So that was 2.1. We're going to 2.2. We're talking about the input and output. So input is what's coming into the program, output is what's going out of the program. Okay? In real life, a lot of our programs are running in the middle of the night because that's the slowest time for the computer. So when it's running in the middle of the night, I don't have somebody over there to enter the data. So we're going to be reading from a file. And anything happens, what we're going to do, we're going to write it to a file, either a error file or a log file or another file that another program is going to come pick it up. So in real life, what we're going to do, we're going to read from a file, we're going to create our own file, put it over there, another program is going to come pick it up and read it and do it something else. So that's what's happening over there. For now, what we're going to work with is the standard input and the standard output. The standard input is the keyboard. So typically, if I'm not using the other inputs, it's coming from a keyboard. And a standard output, of course, is going to go to a monitor. So, when we're talking about the output, the stream is going to be two of less than sign together. That's called insertion operator. That's going to do the for cout. So I can put those things in one line or two line. Remember, if I don't have a semicolon at the right here, I can just put them in here, or I can put that one to the next line. And \n means what? Next line, right? Another thing that we want to be careful is when we are displaying something, we want to look at the display, and if it's not good, we have to fix it. So if my display is next to each other, I got to go back and add some spaces. So here on the suggestion here is I have a space right here, so my display is going to look a little nicer. We got to think about those things. So if I don't want to put it in one line, I can put it in two lines. One option of putting it in two lines is put the 2C out and put 2 semicolon. If I have something that I can do the calculation in that area, I can do that too. If you get to some large companies to work with, sometimes they have a QA which comes and check your code for readability, and they might tell you not to do this or that. So some QAs don't like to do the calculation on the C out. So here is doing the price plus tax. So in some QAs, they would ask that you would create a variable, do the calculation outside, and then do a C out. So basically what they want to do is the input, the processing, and output would be totally separate from each other. So you would do your processing somewhere, you would do your output somewhere, and you're going to do your input somewhere else. We will see that in few chapters coming up, maybe chapter 6 or 7, when we learn about the functions and how we're going to separate these things. So over there, we're going to emphasize on this more. Yes, sir. Okay, one of the things that you learn later on is called functions. Of course, the next class you will learn about the classes and objects. So one of the things that we want to do is called reusable code. So if I want to move, basically I want to make it portable. So first of all, if it's separate, I can understand it better. So I know this is the input section of my program, this is the processing section of my program, and this is my output. Now, only that, now I can take those things and give it to other people to do it. So you're going to be responsible for the output, play with the output, figure out the best way that's going to display. You don't even care how is it coming to you. And the other person is going to be working on the input, creating the menu and all those things for the input part, and other people are going to be working on the processing, that how is this whole thing's going to work together. So now I can take this output and put it in another program, it's going to work. Or I can take that input and put it in another place to work. So basically make it modular programming, and later on you learn about the object-oriented to make the objects out of them so you can use it some other places. Good questions. So if I have two double code is looking for a string. Okay, so I can potentially have empty string that would have nothing in it, or I can have one with the one space. So this is going to give me a space, and if I do nothing in there, basically it's nothing. So alright, we talked a little bit about the reusable code, and a part of that is if it's already there, we are not going to invent the wheel again. So if it's out there and we can use it, let's use it. So some of the code that's already written is going to come to you in a library. So when I download any kind of a compiler or editor, they're going to have a library downloaded to the machine. And that was the problem, to connect your editor to the compiler sometimes for the directory to find it. So when we put the pound include, it's going to go up there to the library, and it's going to pick up a bunch of code that's related to this IO stream and actually bring it and physically put it on top of your program. So if you compile your program, even though it's a small program, all of a sudden becomes a larger program, because it's going to go and bring actually the code from that library and bring it in. Which libraries do we need? Which pound include do we need? We're going to learn it as we go along. The idea here is if I don't need piece of a code, I don't have to put it in my program. I've seen some people put tons of pound include in the program. It's just going to make the program larger. It's not going to hurt the program itself, because if you have extra code, it's not going to do anything with it, but it's not efficient. So another thing that's coming up is called using namespace std. When you learn about the classes, when you learn about the objects, one of the things is when you want to use some functions, you have to say which function this is connected to. Right now, you're not going to be worried about those things, but if I don't put this using namespace std on top of my program, every time I use the cout or cin, I have to put std : cin, std : cout, because I don't want to do that throughout my whole program. I'm just going to say using std namespace, and whenever it goes at the look at the cout, it doesn't know which one belongs to. It's going to go and stick it to this one, so I don't have to keep writing it down. For now, you just put it on top of your program. You not worry about it. Escape sequence. Escape sequence is inside your double code, and basically it has a special meaning. Remember, double code means a string. For the compiler, it just look at the double code and say, okay, this is what you want as a string. I'm going to take it and put it as a string. But then I say, you know what? There are some things I want to do inside my string that I want the compiler to pay attention to. And that's where I'm going to use the backslash. The backslash means a special character. So when the compiler is going to be looking at my text or string and it gets to the backslash, it's okay, something is going to happen after this that I have to pay attention to it. So it's going to look at the backslash and it's going to look at the next character. So we have a bunch of these things listed to see what we want to do with it. We already know about backslash n, which means carriage return is going to go to the next line, and it's the same as endl. So I have backslash n inside the double quote, endl by itself, they do exactly the same thing. Now other things, we have a bunch of it. One of them is going to be the tab backslash t. If I want to put a backslash on the display, remember the backslash has a special meaning to compiler. So if I want to print a backslash and if I don't say anything about it, the compiler is going to say, okay, what is after backslash? What do I need to do? But if I want to just print a backslash, I'm just going to put one backslash and one after each other. If I want to print a double quote on my display, remember double quote was beginning and end of my string. So if I just want to print a double quote, I put a backslash double quote. That means I'm just going to print that one in there. So we're changing the meaning of those things. One of the things with the double and float that we have a decimal point, it can display multiple decimal points. So we got to figure out a way to control that. So definitely I don't want to have a number with a bunch of the decimal numbers right after it. So we're going to learn how to clean it up. If I don't say anything, it's just going to bring up whatever it has and it's going to display that one. Yes, sir.
So to get 7850,
We're going to go over that in a minute or two. Okay, so we are using something called iOS fixed. So we're going to do a fixed point for notation, and then we have something called the show point. That means to show me even if it doesn't have anything. So if my double has 5 point, doesn't have nothing in there, I'm asking it to show it even though it's not there. And then I'm going to set my precision to 2. So I want 2 decimal point. And what I'm saying is, even if it's nothing in there, put 2 in there. So it's going to put 2 zeros in there. And I want to go, because I said it's fixed, it's only going to show me 2. It's not going to go beyond that. So if I put these things in my cout.setf, and I put in the fixed show point and 2, now it's going we okay with that one? So now the expectation is going a little higher. Your display has to look nice. You cannot have a display that prints a bunch of numbers. The cin is going to be reading from a standard input. So I'm going to ask the user to put something in there, then I'm going to read it. So I'm going to read into some meaningful variable. Cin is going to go read that, and it's going to stop right there. So the space is going to be the stopper point for the cin. And we have to be careful with the not mixing up integer with decimal, because if I am reading integer and the user put 5.25, it's going to go read 5 and it stops right there, because it doesn't read the decimal point for the integer. We worry about those things later on. You don't have to worry about it right now. So cin, just like a cout, I can put a bunch of them right after each other, or I can list them out as one individual per line with the semicolon. So this is a bad programming because I don't like V1, V2, V3. We got to have some kind of a meaningful name for those things. So it's reading it. So it doesn't matter if they put it in one line or in multiple lines. It's just going to read one number. It's going to wait for the next one. It's going to wait for the next one. So the user can put one at a time or put all three of them. It's going to read it. So I'm going to do a cout to display the user what is it I'm expecting. And because this cout doesn't have a ENDL, it's going to stay right there. And there is a space over there. So it's going to display enter your age with a space, and it's waiting over there for the user to put the age. Okay, this is your time. You got to do this. Get a piece of paper, do this. I'm coming around to see who's doing what. You can touch somebody if you want to. What does it say? Input, place a value in the variable. No, it doesn't matter. The idea is using a cin. So I'm going to call your name and you're going to come and write it on the board. Okay, now we're talking about the data types and expressions on 2.3. So, what we are looking at is number 2 and 2.0 are not the same numbers. Okay, one of them is an integer with no decimal point. The other one has a real number. I guess the requirement for this class was Math 9 or something. So you should know the difference between an integer and a whole number, right? Real number versus whole number. So numbers of type int are stored as exact values. Numbers of type double may be stored as approximate value, meaning that depending on how many decimal point do I need, I can move it around. So integer 34, 45, 1, 89, minus 25, as far as it doesn't have a decimal point. Double or float, we can use decimal points for them. Floating point notation, we can have scientific, E for a scientific one. That means what? 10 to the power of 1, 17, negative 6. So, if I have more precision, we're going to need more bytes in the memory. Very large numbers require more bytes of memory. Very small numbers require more bytes of, should be less bytes, right? Very small ones. So the idea is if I don't have a, for example, if I'm using indices, if I use index, number for index, I'm not going to have a decimal point. So why should I save it in a double instead of integer? So these are the data types that we have. Short, also called short int, that's 2 byte. 2 byte means I'm going to have a 32,000, negative 32,000 to positive 32,000. That's the maximum I can have for 2 bytes, which is how many bits? Say that louder. 16 bits. Okay, so 1 byte is 8 bits, 2 bytes is 16 bits. So early on we had 16-bit machines for Microsoft Windows, and then we went to 4 bytes, which is how many bits? 4 times 8, 32 bits. And that's what we have right now. The int for C++ is depending to something called the word. Word is the size of the machine. So the size of my machine is 32-bit. My int size is 4 byte. If I took that one and move it to another machine which is 64-bit, my int is going to grow. That's why when I was writing program in C programming, I was forced not to use int. Either I would use short or I would use long. So long is always guaranteed to be 4 bytes. Short is always guaranteed to be 2 bytes, and I don't have to worry about what machine I'm going to compile it on. Float is 4 bytes, 32 bits, so it's going to go from 10 to the negative 38 to 10 to the power of 38. That's 7 digits. Double is double size of that one. It's 15 digits. And long double is going to be 19 digits. And if we need more than that, we've got to figure out how we're going to do it. So the idea is we want to, before the cost of memory was very, very high, and we had to be very, very careful. Now we're looking at the small footprints, cell phones, little chips that are here and there, especially if you're going to engineering. So some of these things are very, very important to keep in mind, that if I don't need large numbers, I should keep it in a smaller one to be more efficient. If I need the large ones, then I use the large ones. Okay, the other type is called the char. Char is 1 byte which we're going to be keeping one character. It's going to use ASCII table. We looked at the ASCII table on Monday. So we have a 1 byte that's going to keep one character for us. Okay, remember, one character. It doesn't keep the whole string. It's just one character. So if I have one character, I'm going to use a single code. The difference between single code and double code is a single code is one character. Double code is the whole string. So if I put double code, the way that the machine or the C++ compiler understands the string is the end of a string, we're going to have a null character. Null character, you and I cannot see it, but the machine knows. That's a 0 character in the ASCII code. So the difference between double code A and single code A is double code A is actually 2 characters. One is the A itself and a null character. The single code A is just 1 character. Yes?
What happens when you declare a char, but then you put double quotes?
You're going to get an error. It's not going to take it. Because remember, you're taking 2 things and you want to put it in one thing. It doesn't work. And we're going to learn how to modify things to go from larger to a smaller or a smaller to larger. We have to change them, and we can do it. That's not a problem. Remember, if I have a larger thing going to the smaller one, what's going to happen? Some of it is going to get lost. If I have a smaller one that I'm going to be putting it in a larger one, it's okay because I can fill it up with the extra spaces or zeros or whatever. So if I have characters, I can read 1 character at a time. So it's going to go read 1 character and it's going to stop right there. So it doesn't care if it's going to be a space here or not. It's just going to read 1 character and it's going to stay right there. So we're talking about enter 2 initial without any periods. We're reading symbol 1 and symbol 2, and the 2 initials are, it's going to print it out once with the space, and we can put actually 1 space in there. Okay, there is another one. It's called the type string. We did not have that in a C language. It was added later on in C++. So when you are writing a program and you define something as a string, most of the editors are not going to highlight it as a reserved word because it's just a class that has been defined later on, and that made our life much, much easier. You will see that at the end of the course how we were doing it before with the C language, and some of you might have to do it that way if you're going to the engineering. But for C++, we will have a string, and we have to do a pound include a string to be able to use it. If I don't have pound include a string, it's not going to let me use it. So the difference is discussed in chapter 8. We will get into chapter 8 at the end of the course. We're going to look at these things, and I can define it as a string, so I can have a string name and I put the whole string in there. Because the string is a class, we're going to create an object of that class. It has some functionalities that we can use. So some compiler is getting smaller and smaller to handle this stuff. The idea of the C, C++, and Java is not to crash the program as much as possible. So if we can figure out something, we can do it, and of course the bookkeeping at the back end is going to be less. So some compiler is going to let you put 2.99 and just going to take the 2 out of it. So remember, I have a larger one, forcing it to go to the smaller one. I'm going to lose something. And because it's small enough, it knows that I need the number to the left of the decimal point, so it's going to just take 2. If the compiler is not smart enough, I have to force it to be that way. One way of forcing something to go from double to integer, let me see if I have it here. I can actually put the word int in a parenthesis to force my double to become integer. So if I have a variable that is got the 2.0, I can put an int inside the parenthesis. So open parenthesis, int, close parenthesis, or we can use the typecast, and that would force the number to go from double to integer. Then I'm going to assign it to int. But if I go the other way around, it doesn't matter, because if my int has value of 2 and I put it in a double, it's just going to add zeros at the end of it, put a decimal at the end of it. So a smaller to the larger, we don't have no problem. Larger to a smaller, we're going to lose some stuff. We can get the value of a character. That's going to go and get the numbers from the ASCII table. Remember, our C++ program is comfortable with numbers. So most likely it's going to be saving character A as a number 65. So I can actually put it as a number instead of the character. Another thing that was introduced later on that we didn't have it early on the C programming was Boolean. Boolean is going to be a true or false. It's just going to be, we used to use a 0 and 1. If I was using a 0 and 1, I had to use one int. And one int in this system is how many bytes? 4 bytes. But now I'm going to change it to 1 byte to just use a 0 and 1. Basically, it's true and false. I can actually say true and false. We will take it. In reality, if I want to put a number, 0 means false. Everything else is true. So if I put 0, that would be false. Everything else is going to be true. So 255 is true. Negative 35 is true. 0 is false if I want to use integer. But I can use Boolean to use it as a true and false, and I can actually write true or false. Arithmetic. So we're going to be working with some arithmetic operation that would be plus, minus, star, division, and so on and so forth. We can use a star for multiplication. One of the things that we have to keep in mind is if I have an integer divided by integer, I will get integer. I do not get the double. So whatever I'm using is going to stay the same type.
If you want to change that, like if you want to say, like you want to write a program that can divide two integers and give a fraction.
We're going to force one of them to be double or float. Remember, we can force a number to go from one to the other one. So if I have an int that is 3, I want to force it to be double. I'm just going to put a parenthesis double in front of it. Or I can multiply it by 1.0 before I do any calculation. So if I do division of 3, or let's say 5 divided by 3, okay? If they were integers, let me see if I have it here. Okay, so if I divide 5 by 3, and if they both are integer, I'm going to get what? 5 divided by 3. I'm going to get 1. 5 divided by 3, if they both are integer, I'm going to get 1. It's going to give me the result of integer. 3 divided by 5 is going to give me 0. Now, I have to force one of them to be double or float, then it's going to work. So if I had integer 3, integer 5, and I want to divide them, either I'm going to multiply or divide or put a dot somewhere. So the divisor is 3, dividend is 5. I'm going to say dividend times 1.0 divided by divisor, or I'm going to put the word double or float at the beginning inside the parentheses.
So you can like leave it small, like you can leave it as an integer to save space, but then just tell it if you do a division, then first multiply something by this.
Right. Whenever I do the division, flags come to my mind and says, are these numbers integer or not? If they are integer, is that the way I want to do it? Because sometimes that's the way I want to come get that one. And if it's not, then I have to change it to the float. We can see the wrong results. Yes?
So if you divide an integer by a float, will it be a float?
That's correct.
Okay.
If one of them is going to be different size, it's always going to promote to the higher number. So if it's an integer divided by float or a float divided by integer, it's always going to be promoted to the float. So a small, if you have mixed, it always goes to the higher one. Good questions. There is another one, it's called percent. This only works with the integer. It does not work with the float or double. The reason for that is going to be remainder. When I'm dividing float or double, any kind of a decimal number, I don't have any remainder. It's just going to come up with 0 all the time. But if I have an integer divided by integer, then I can have a remainder. So 5 divided by 3 is going to give me 1, and 5% 3 is going to give me 2, because the remainder is going to be 2, right? So one of the things that is talking about over here is please use spaces to make your code readable. X, Y, and Z are not good variable names, but still if you're using it, if you put some spaces, remember spaces doesn't have any meaning, but I can put as many as I want, or use some kind of a parentheses. The order of operation applies over here. Sometimes some of us have to think about which one comes first. Is it the multiplication before addition or what? So for that case, if I don't want to worry about it, or I don't want my future readers to worry about it, I just put them in the parentheses. So instead of saying x plus y times z, which what? The multiplication is going to happen first, I can put 2 of them inside the parentheses, so it's going to make it easier to read and basically shows what I mean. Because sometimes I want to do x plus y first, then multiply it by z, and if I write it like x plus y times z, it's not going to do it that way. But that's the math problem, that's not a computer problem, right? Operator shorthand. So if I want to, if I have something on the right, remember it's going to do the right side first, and it's going to assign it to the left side. So if I have a number that's called count, and I want to add 2 to it and put it back, so let's say the count is 1. I'm going to add 2, that's going to be 3, and then I put it back in the count. So my count is going to be 3 now. The next time is going to be 3 plus 2 is 5. So the way to do it is I'm going to be writing count equal count plus 2. A shorthand for that is plus equal to. Plus equal means that one on the left is going to be repeated on the right. I can do that for the multiplication, I can do that for the division, I can do that for the percent. That way I don't have to write it like that. I have been working for companies that the QA would not let me do that. They were saying that the only way it's acceptable is to write it out. The readability was important to them. But it's a shorthand, you don't have to use it that way, but to me, one of the things I liked about C++ was less typing. So if I can find a way to type less, then I use it. Any questions on this one? So we almost done. We're going to the simple flow of a control. we can do different way. We're going to be writing steps of doing this. I strongly encourage you to write your algorithm of your program before you start coding, because when you are writing codes, your concentration is how to make this work. So you're not thinking as much as if you are sitting on Microsoft Word and typing things out, or get a piece of paper and writing things down. Now you're going to be thinking about what's the flow of your program, and then you can define how do you want to write it. Do you want to write it as a rate times hours, or do you want to write it as rate times 40 plus 1.5 times rate times hours minus 40? So we can modularize it. We can put it as small variables after each other, or you can put the whole thing in one line if you want to. Of course, when you're doing that, sometimes it's not easy to read. So if I had rate times 40 plus overtime, then it would make it easier to follow. The branching is, I'm going to be checking to see if a condition is going to be true. The if is going to check. So I'm going to say if hours is greater than 40, that means I have an overtime. Now I'm going to go calculate the overtime. But if the hours are not greater than 40, I don't have to calculate the overtime. So I don't have to worry about overtime. So the only time I'm going to be doing this calculation is if my hours is greater than 40. So for me, if I would do this one, the gross pay is going to be the same all the time. So I would calculate gross pay outside, and then if it's overtime, I would calculate the overtime and add to the gross pay, because gross pay is going to be the same if I have overtime or not. Or maybe the 40 is going to be different. So we're going to be using something called if statement, and if can go with the else. If a statement, if it's only one single statement, we do not need braces. If I have more than one line of a statement, I need braces. So here I only have one line of code, gross pay equal rate times 40 and the rest of it. So it's one line of code, that's why I don't have no braces over here. So it's going to do, if it's greater than 40, it's going to do this one, else it's going to do this one. So either or, it's not going to do both of them. Either going to do the first one or second one. So we have here a sample of a program at 2.7 that shows how is it working inside the program. I'm going to read the hours, and if it's greater than that, well, I'm going to do this, else I'm going to do the other one. If I have more than one statement, I've got to use braces. Once again, every time I'm using braces, everything is going to be shifted to the right. So the code inside, it's going to be shifted to the right, so I can see where is it starting, where is it ending. So this if statement starts here with the braces, everything else is going to be done there, else and that. So if I looking at this, I can see that my if statement starts here, finishes right here, else starts here and finishes right there. So the Boolean expression is going to ask if it's true or false. So when I'm checking hours greater than 40, it's going to be either true or it's going to be false. There's not going to be any other value. I can use greater than equal, not equal, and this is the part that most of the students are going to have a mistake sooner or later. The equal is not the 1. Remember, the 1 equal sign is assignment. If I say if hours equal 40, it's going to assign 40 to hours, and it's always going to be true because 40 is always equal 40. That's why I have to use 2 equal signs. If I use only one single equal sign, that statement is always going to be true, it's always going to happen. It's the assignment. I have to use 2. So if I want to know if hours equal 40, I have to say hours equal 40. So if I'm looking for the equal, I'm going to use equal equal. If I'm using not equal, I'm going to use the exclamation equal sign, and less than, greater than, greater than, and greater than equal. Any questions on this? We can mix them up. We have and we have or. And means both condition has to be true. The first condition and the second condition. You are working in some assignments on the other book that talks about and or. So the and it means that both sides have to be correct. So if I say if 2 less than x and x less than 7, both condition has to be true for it to work. What's going to be the answer? I need something that 2 is less than x and x is less than 7. What number is going to work for that? 3, 4, 5, 6, 7? No, because 7 is not less than 7. The or is going to be either or. Sometimes we're going to confuse things, even though we think that we are talking about and is actually or vice versa, especially if you're using the not on that one. So or has to have one of them only two or both sides to be true. So if one of them is true, the whole thing is going to come up true. The only time it's going to fail if both of them are going to fail. Not is going to change the value. If it's true, it's going to make it false. If it's false, it's going to make it true. We cannot do 3 of them right after each other. So if we have that, we have to check it for and. We cannot use if x less than y less than z. So once again, the equal sign is assignment. If I put if x equal 3, that condition always going to be true. I have to be sure I'm going to be using if x equal 3. We can mix up the if statements. We can have more than one at a time. So I can have if else, if else, if else. Let me hold on to this for next week. I think I'll cover a lot of things for you guys. I'm going to keep the loops 2.4, 2.5 for Monday. Even though we're supposed to do computer science on Monday, I'm going to cover these things. I think we covered a lot of things. So be sure that you're going to read up to this point, and then we can do this too later, the loops. Okay, I'm going to upload the assignments for this chapter, and if you don't get to the loops, that's okay. We can do something by Monday, and then we can do that one. Any questions on this? No questions? Okay, he's going to come and show you how to look at this stuff on Blackboard.